Okay guys, so what I want to talk about today is how do you remember all of the information on the unit circle? So here is a totally filled out unit circle with the degrees and the radians and the coordinates of every point. And yesterday we sort of used geometry to derive the coordinates of these 3 points and then used symmetry to get the coordinates of all of the others. So how in the world are you supposed to remember this? First of all, let me just sort of make the observation that all you really need to do is remember the coordinates in this first quadrant. Why is that? Because if you know the coordinates of, say, pi over 6, then all you have to do is remember that every other pi over 6 angle, that's this one, 5 pi over 6, 7 pi over 6, and so on, every other pi over 6 angle has the same coordinates as this one, except some of the coordinates could be negative depending upon the quadrant in which the angle sits. So if you know the coordinates of pi over 6, then you automatically know all of the pi over 6 angles. And therefore, if you know all 3 of these, then you automatically sort of know all of the angles in the unit circle. You can work all of them out. So all we really have to do is make sure we understand how to remember these points here. So what I want to do is just sort of focus on this quadrant right here, this top right quadrant, the points in the first quadrant. So, first of all, this bottom point here, 1, 0, and this top point here, 0, 1, it doesn't take much to remember those, right? Like, it's pretty obvious that this point is, it's a unit circle, so this point is 1 unit to the right, so of course the coordinates are going to be 1, 0, and same with this one. It's really these 3 points that sort of trip people up, and so I'm going to really focus on how to remember these 3 points, the pi over 3, pi over 4, and pi over 6 angles. What I want you to do is just sort of notice the values that actually appear in the coordinates. You've got 1/2, root 3 over 2, root 2 over 2, and that's actually it. There's just those 3 values, 1/2, root 2 over 2, and root 3 over 2. So I just want to sort of write those down and talk about them a little bit. So we have 1/2, we have root 2 over 2, and we have root 3 over 2. It might seem at first a little bit difficult to remember these values. However, I do want to point out one fact. Just note that 1 is equal to the square root of 1. Those two things are the same. The square root of 1 and 1 are the same. Therefore, if you wanted, you could actually rewrite that very first expression, 1/2. You could replace the 1 with root 1 and rewrite it as root 1 over 2. Then your 3 values are root 1 over 2, root 2 over 2, and root 3 over 2. It is not hard to remember these 3 values. It's just 1, 2, 3 in the numerator with square roots, and then 2's in the bottom. Of course, generally you shouldn't write root 1 over 2. That's not simplified. You should bear in mind that the value of this thing is actually 1/2, but this can be helpful for remembering the 3 values that actually appear in that top right quadrant. Now, the key thing to remember, or the key thing to note about these 3 values, is that as I've written them, they are actually in order. In other words, 1/2 is less than root 2 over 2 is less than root 3 over 2. If you don't see why this is true, just forget temporarily about the denominator of the root 2 and look at the numerators. Surely root 1 is less than root 2 is less than root 3, so dividing by 2 doesn't change any of that. The ordering is still preserved. Knowing that this is the smallest and that's the middle and that's the largest value is really the key to remembering where all these values actually go on the unit circle. And I'll show you what I mean. So let's pretend that we have the top right portion, that's the first quadrant of the unit circle, and we're interested in sort of recalling the coordinates of the 3 points that I mentioned. That is, the points associated with the angles pi over 6, pi over 4, and pi over 3. And my objective is to just sort of try to understand what are the coordinates of these 3 points. I know the coordinates of these 3 points are made up of these 3 values here. I just sort of have to know which ones go where. So maybe I'll start with pi over 4. So pi over 4, what you might notice is look at the x-coordinate, or think about the x-coordinate of this point. Do you notice that the x-coordinate, or the horizontal position of this point, is in between the other two? This x-coordinate is in between these other 2 points horizontally, which means that the x-coordinate of this point must be in the middle of these 3 values. In other words, the root 2 over 2 has to go here. And the same thing is true for the y-coordinate. The height of this point is in between the heights of the other 2 points, which means the y-coordinate here must be the middle value. That's root 2 over 2 as well. The same argument gives you the other points. If you look at pi over 6, this point is furthest to the right, and therefore its x-coordinate must be the largest value. So that must be root 3 over 2. Its height is very small. This point is lowest off the ground, if you like, compared to the others, which means that its y-coordinate must be the smallest value. That's 1/2. And then finally, for pi over 3, the situation is reversed. This point is closest to the y-axis. Its x position is very small, so the x-coordinate must be 1/2. And this point is the highest off the ground of the 3. Therefore, its y-coordinate must be the largest value. That's root 3 over 2. So you can see sort of how to recall these things. So let's just put this into a single example, because I want to show you how I actually think of this. So let's suppose that you've got no unit circle in front of you, and you're trying to evaluate something like cosine of 2 pi over 3. How in the world are you supposed to remember what's happening here? Of course, this will be the x-coordinate of the point associated with 2 pi over 3, but what is that coordinate? Here's how I think of it. First, you should think about just plain old pi over 3, right? That's the pi over 3 angle sitting inside of the first quadrant. Think about the coordinates of that point, and then remember that the coordinates associated with 2 pi over 3 will be the same as this one, except that some of the coordinates might be negative because this thing sits in the second quadrant. So what are the coordinates of pi over 3? Well, I know that of these 3 angles, this one is pi over 6, this one is pi over 4, and this one is pi over 3. It's like the largest one. Thinking about the coordinates of that point right there, what I say to myself is, oh, that point is really high off the ground. Its y-coordinate has to be very large. Its x-coordinate has to be very small. So the largest value, that is root 3 over 2, has to go here, and the x value has to be very small. That must be 1/2. Okay, so the coordinates of pi over 3 are these right here. The coordinates of 2 pi over 3, 2 pi over 3 sits somewhere over here, will be exactly the same except for what? Well, because this coordinate is sitting in the second quadrant, the x-coordinate has to be negative, which means that the x value has to be negative 1/2. The y value will still be positive root 3 over 2. So what's the cosine of 2 pi over 3? Well, that, of course, is just the x-coordinate of this point. In other words, it's negative 1/2. So the answer is negative 1/2. One final thing. I find that, generally speaking, what people really screw up when trying to remember the unit circle is they mix up the coordinates of pi over 6 and pi over 3. People pretty much never forget the coordinates for pi over 4. They always get that right. The problem is really that they mix up these two, pi over 3 and pi over 6. They are very similar. How do you remember which one is which? Well, when I'm thinking about pi over 6, what I think to myself is, that's the really small angle. That's like the smallest of the 3. That's the little one. And I think about the positioning of this point right here. And all I do is I sort of remember, that point is a lot further over than it is up. Do you see that this point is further to the right than it is up? Because it's further to the right than it is up, that means the x-coordinate has to be